Good morning, good afternoon, everybody. This is a short presentation on coastal nature-based solution and landscaping. This work has been started and accomplished by a strong collaboration between research institutions such as the University of Bologna and CMCC, the Euro-Mediterranean Center for Climate Change, and the Environmental Protection Agency that formed our basic stakeholder co-design partner. In this short talk, I will give you details on coastal ocean hazards, impacts, and the way that they can be solved with nature-based solutions. Then I will show you an approach, rather a new one in the past 20 years, where digital twin methods could be used to assess the effectiveness of nature-based solutions, and then conclude with some comments. The coastal zone is a highly populated area. Approximately 40% of the world ocean population lives within 100 kilometers of the coast. This population density is due to the numerous benefits that coast provides, such as access to fishing grounds, transportation, and recreational activities. But the coastal areas are threatened by many climate-related hazards, such as sea level rise, erosion, storm events, and flooding. Coastal nature-based solutions are solutions that are offered by an approach that is inspired and supported by nature, which are cost-effective, simultaneously provide environmental, social, and economic benefits, and help build resilience. So they are probably the optimal choice, but they are difficult to implement and to choose among the different options. It is crucial to implement sustainable coastal management practices to reach coastal resilience. Here we consider nature-based solutions that are defined as we said, and in the picture you see some of the most commonly used nature-based solutions such as mangroves, coral reefs, elevated coastlines, dunes. Today we have a new methodology to test the effectiveness of the coastal prediction nature-based solution that stems out of the operational availability of observations and validated models. So first of all, we ask ourselves, what is the solution to be tested? And in this case, I will show you results on local seagrass, meadows, and dunes, sand dunes. And we ask ourselves, are these natural environments which should be restored, capable of reducing wave surge amplitude and inundation areas? So we have a digital twin framework that is composed of many models, partly coupled. One is a wind wave model, a circulation model, a morphodynamic model, and then we have a practice in calibration and validation with local observations, maybe collected for the digital twin. And we have this background information coming out of operational models that give the background flow field. And we ask what-if scenarios, such as what is the reduction in the wave amplitude due to seagrass types and landscaping, and what is the impact of dunes and seagrass on the coastal inundation area. These are two papers that illustrate the results of our work in the past 3-4 years, and we these examples are referred to the Emilia-Romagna coast. The investigated nature-based solution for the Emilia-Romagna coast are seagrass meadows, in particular Zostera marina or Cimodocea nodosa, and artificial dunes done, however, completely with natural materials. But what happens when seagrass is present? Seagrass offer a roughness that makes it possible to dissipate energy in the ocean. And here is a schematic of the reduced wave height that the presence of seagrass can allow, extracting energy through turbulence and drag from the waves. Our digital twin for nature-based solutions try to answer the question, are seagrass meadows capable to protect the coast? And here you see the different type of seagrass that is available in the Mediterranean Sea, different kinds of Zostera, Posidonia, and Cimodocea. But more important for this talk is that we try different landscaping of the seagrass. See, here you see 4 different realizations with continuous strips of seagrass put into the model to simulate the presence everywhere of Zostera or Cimodocea. Then a second landscaping where we had more irregular areas, bunches of seagrass, as outlined by the orange triangles. And here we have an alternation between a continuous strip and clusters. And the last one, clusters with broken lines, which most adequately simulate the natural behavior of seagrass meadows. So our results here are outlined for 2 kinds of landscaping of the seagrass. The first is the continuous strips with clusters, and the third is completely irregular strips and clusters. And you see the colors when they are from yellow, green to blue, they indicate reduction of amplitude in the waves. And the isolines, the black lines here, indicate depth of the water. So for our coastline, the 5-meter depth is very close to the coast, as well as the 10-meter. And this is facilitating the possible restoration of seagrass meadows in this area. Now you see that the yellow and green colors are more abundant in the case of the broken strips. And some also along the coast you see very much extended blue areas where the reduction amounts to 70%. So this landscaping of seagrass offers the possibility of having a major reduction in specific areas as needed, depending on the incidence of storm surges. How about inundation? So here we see the effect of dunes and seagrass. The normal conditions due to a large storm are outlined on the left, and you see a large area inundated with quite a large amount of water. Amount of water is shown by the blue color. The intermediate result here is where vegetation of the kind that we have shown is implemented in the open area, and the vegetation is capable of reducing not only the area but the amount also of water that enters the land. The major effect is due to the long red strip of dune that drastically reduces. So maximum inundation reduction is obtained by the dune, but the combination of the two is actually optimal. In conclusion, coastal hazards and climate impacts require ecosystem-based solutions. Nature-based solutions' effectiveness against storm surge can be numerically simulated with a digital twin modeling framework. Seagrass meadows are powerful protections for the coastlines, and the positive impact depends on the landscaping of the restored seagrass. Combined dune and seagrass offer an effective solution along the Emilia-Romagna coastal strip to defend the coast from storm surges and inundation. Thank you very much.